Hello and welcome to another Science mini-masterclass video. My name's Tim and I'll be helping you to secure knowledge of the facts and how to apply these effectively to exam questions. As always, there'll be plenty of hints and tips from me, as well as common errors to watch out for that I've found from my examining experience. In this session, we are focusing on concentration calculations, which is part 3 of my calculations in chemistry series. We will of course require the use of a calculator for this session. Final reminder that everything I do during this session is applicable no matter what exam board you are studying for. Let's get cracking. What is a concentration then? What's it actually referring to? Well, it's a measurement of the amount or mass of solute per volume of solvent. Now in this case, solute is shown here as solid copper sulfate powder being added to a solvent, and in this case it would be water. What if I needed to work out the concentration of that solution? Well, I'd be using one of my two golden triangles. These are golden equation triangles of quantitative chemistry. We have to learn these ones off by heart as there is no chemistry formula sheet. So I'm after the C, part of the MCV triangle. So I'm doing the mass of solute divided by the volume of solution formed. Please note, if you are a higher tier student and you are going to need to perform molar concentration calculations as well, the value for moles can be substituted in place of mass there. So M can represent moles as well as mass. That one though, in another video. What if I had to perform unit conversions? Well, if I was after the concentration in grams per centimetre cubed and I were given the mass in milligrams, I'd need to convert that to grams by dividing by 1,000. If I were trying to calculate a concentration in grams per decimetre cubed, but I were given the volume in centimetres cubed, again, I would need to convert that by dividing my centimetre cubed value by 1,000 to convert it to decimetres cubed. Some common unit conversions on the left-hand side there. Please note, if you are an Edexcel student, you'll see grams per centimetre cubed expressed in this format and grams per decimetre cubed expressed in this format. They mean exactly the same. Grams multiplied by centimetres to the -3 is the same as grams divided by centimetres cubed. Some exam questions then. I'm going to tackle these first few and model how to structure an answer accurately. I'm using the bug technique. It's a calculate question. I'm going to show my working out and obviously use my calculator. I've decided to annotate the question to flag what those quantities actually are. We've got a mass and we've got a volume. I can see from the answer that I'm doing grams divided by centimetres cubed here. So even if I'd forgotten the MCV equation triangle, that's a big hint for what I'm going to have to do with these two numbers. Concentration equals mass divided by volume, M divided by V. I substitute my values, including the units, because this will help me decide whether or not I need to perform a unit conversion. In this case, because the answer requires the concentration in grams per centimetre cubed, and I have a mass in grams, and I have a volume in centimetres cubed, no unit conversion needed. I've got 1 mark in the bag. Second mark is going to be for giving my answer to 2 significant figures. I'm looking at the 3 and I need to decide, do I round up or down? In this case, obviously, due to the third number being less than a 5, I'll round down to 0.43. In this case, I've been asked to calculate the mass of copper sulfate, having been given a volume and a concentration. I start by writing out the equation I'm going to use, M equals C times V. I substitute the values, including the units, and I can see commonality between the unit of concentration and the unit of volume, so no unit conversion needed. I do, however, to get the second mark, now need to round this to 2 significant figures. So I'm looking at that 7 and deciding whether I round up or down. And in this case, I'm going to need to round that up to 18. Final one from me. I've been asked to calculate the concentration of sodium hydroxide in grams per decimetre cubed. Again, I've decided to assign what those quantities actually are telling me in the question. I've written out the equation I'm going to use. However, I've flagged here that there's a difference between the volume and the concentration that I'm looking at in terms of their units. So I've spotted that I'm going to need to convert my centimetres cubed into decimeters cubed if I need to give a concentration in grams per decimeter cubed. So I've performed that unit conversion here. I've then substituted my value for mass and my value for volume to give me 2.188 to three significant figures. I'm looking at that 8 and I can see I'm going to need to round that up to 2.19. One for you to consider then. We've got another question and a previous student has had a go at this, their answer being in purple. I'd like you to pause the video and have a think about how many marks that response would get. So then, in this case, we can see the student has correctly used the MCV triangle to work out concentration. They've only got 1 mark though. The reason being, they've unnecessarily done a unit conversion, and this is something I see a lot of students do. They get trigger happy with their unit conversions. Seeing as the concentration needs to be in grams per centimetre cubed and the volume is given in centimetres cubed, they did not need to perform this step. So they simply needed to do 8 divided by 32 as part of this calculation. Okay, 2 for you to have a go at. I've included the MCV triangle on the right hand side for now, and these are 4 marks worth of questions, so you should spend no more than 4 minutes on this. Pause the video and I'll review in a moment. Okie doke, for the first one, we're after a concentration. So we're doing mass divided by volume. We've substituted the values, including the units, and because the units are in grams and centimetres cubed, and we want the concentration in grams per centimetre cubed, there was no unit conversion required. That given to 2 significant figures is 0.046. The second one required the calculation of a mass, so we're doing C times V, concentration times volume. Again, values and units substituted. There's commonality between the unit of concentration and volume, so no unit conversion needed. 1 mark for the working out, and we've got our final answer there of 200, gaining us the second mark. 2 marks for the final answers there. And lastly, 1 more to consider, and I've bugged the question as a little bit of assistance. 3 marks, no more than 3 minutes on this. Pause the video and I'll review in a moment. Right then, in this case, mass divided by volume equals concentration. No mark for that, but it's worth writing the equation out nonetheless. We substitute the values, however, we can see that we do require a unit conversion. Okay, so as part of this, we've needed to then resubstitute the value of volume in decimeter cubed format to then give us an answer of 250 grams per decimeter cubed. You will get 1 mark for showing that you can perform the unit conversion correctly, 1 mark for at some point, whether it be first or after the unit conversion, showing that you can substitute the values correctly, and then of course a mark for the final answer. 3 marks for the final answer is up for grabs there. And that's mission complete. Concentration calculations boxed off the list. I hope you found that useful. If so, please do hit the like button. And for more Science Mini Masterclass videos, please subscribe to my channel, Science Mini Masterclasses. And I'll see you in the next one.